Hello everyone. So in this last solutions lecture video, I'm going to be talking about dilution calculations. Dilution calculations implies that the concentration of a solution is going to be decreasing. Hence the term dilution. Dilution is all about the dense distances between solute particles. So in a highly concentrated solution, okay, so let's compare 10 molar sodium chloride versus 1 molar sodium chloride. The distances between solute particles in a 10 molar concentration is way smaller. So the solute particles are going to be closer together. And the reason why is there are more particles of sodium chloride in a 10 molar solution than a 1 molar solution. Okay, so if I take a 10 molar solution and add more water to it, that's actually what dilution is. You're adding more water to something, right? What actually happens then is the more solvent, in this case the water, you add to the solution, the more the distances between two solute particles actually become. And therefore, that's where dilution comes from. If a drink is too hard for you, let's say, well, you can dilute it by adding juice or water to it, and that actually becomes more palatable. Okay, and dilution calculations can be expressed by this formula: C1V1 equals C2V2, whereas the number 1 is always the initial conditions, and the number 2 is always the final condition. So we might as well do an example here. So 10.5 mils of a 2.5 molar solution was mixed with 190 mils of water. What is the new concentration? Right? So we need to have the first concentration is given to you. And what is being asked is the second concentration. What is the new? So we're being asked for V2, right? Well, I'm sorry, V2. That was a mistake. I didn't mean that, folks. So new concentration means in this case, concentration is C. My bad. It's late. Need to go to sleep. All right. So if we write out the unknowns, we actually have C1, 2.5 molar, V1, 10 milliliters. C2 is X, that's the unknown, and volume 2 has to be, anytime you see water, there has to be an addition. So we're going to add this 190 ml of water with that original 10 mils, which is equals to 200 mils. It's a straight chug and plug in the numbers. As you can see, this is the unknown. Whatever number is by the unknown, we're going to divide both sides by it. And as you can see, since we're dividing the mils, what unit is left behind? What unit is left behind is a unit concentration, which is smaller. And that's why the final concentration, if I diluted it with 190 mils of water, is 0.1 molar. Note, the initial concentration always has to be bigger than the final concentration. One more time, this number must always be bigger than that number, which implies that the second concentration, C2, is always going to be less than the concentration for the initial conditions. Okay? Here's another example. Hopefully I don't mess this up this time. Okay. What is the final volume of a solution if you started with 50 mils of this and ended with 2.5? So in this case, we are now, final volume, we're looking at V2. All right. Again, V2 is unknown. We divide both sides by 2.5 molar. So the molar cancels. What unit's left? Look at that. Milliliters, which is, all right, what we wanted. So in this case, the final concentration, V2, is 200 mils. All right, now I want you to notice a trend here. So in concentration units, the concentration of the initial conditions is always going to be higher than the second concentration. However, in volume, the second volume is always going to be greater than the first volume. So C1 is always going to be greater than C2. And V2 is always going to be greater than V1. Because in order for something to be more dilute, it has to have more volume. Okay, I hope that makes sense. So I think that is it, everyone. So, or there's one more example. I guess, yeah, I already forget telling you, everyone need to go to sleep. How much water must be added to this to end with a 10 molar solution? Now, in this case, it's actually a two-part problem. So in the first case, it's just going to be C1, V1 equals C2, V2. So we actually have C2, we need to find V2. Right? Again, it's divide both sides by 0.10 molar. What happens to the molars? The molars cancel. You're just left with milliliters. So 60 mils is the total volume, and it should be correct, right? So this concentration is bigger than the second concentration. Check. This volume has to be bigger than the first volume. 60 mils is bigger than 12. Check. That's good. But that question doesn't end here because it's saying how much water must be added. So the total volume at the end has to be 60 mils. But we're only starting with 12 mils. So guess how much mils of water we need to add? We need to add 48 mils of water. Because 48 plus 12 equals 60. Alright, so I hope that you have mastered the art of concentration units, the effects and colligative properties and dilution calculations in this learning plan.